अस्सलामुअलैकुम स्टूडेंट्स। आज का हमारा टॉपिक है इंट्रोडक्शन ऑफ सॉलिड स्टेट फिजिक्स चैप्टर नंबर 1 क्रिस्टल स्ट्रक्चर। ये और टॉपिक है इंट्रोडक्शन ऑफ सॉलिड। सबसे पहले हम सॉलिड की डेफिनेशन देखते हैं। द सॉलिड्स आर द फॉर्म्स ऑफ मैटर इन विच एटम्स एंड मॉलिक्यूल्स आर स्ट्रांगली बाउंड एंड maintain definite volume and shape unless changed by applying external forces। यानी कि सॉलिड मैटर की वो फॉर्म है जिसमें एटम्स और मॉलिक्यूल स्ट्रांगली बाउंड होते हैं और वो अपने डेफिनेट वॉल्यूम और शेप को बरकरार रखते हैं जब तक उन पर कोई एक्सटर्नल फोर्स अप्लाई ना की जाए। सॉलिड स्टेट फिजिक्स। Solid state physics is the study of the physical properties of the atomic or molecular matter in the solid state. These physical properties include crystal structure, bonding, thermal, electrical and magnetic properties. Next है हमारे पास classification of solids. On the basis of structure, solids can be classified into two categories: crystalline solid, non-crystalline और amorphous solid। सबसे पहले हमारे पास crystalline solid। When the constituent atoms of a solid are arranged in a definite, regular and repeated geometric pattern throughout the entire three-dimensional network of the crystal, then the solid is called a crystalline solid. Examples of crystalline solid include diamonds, metals, rock salts, quartz, sugar, ice। आगे हम देखते हैं इसको। Structure of crystals has particular arrangement of particles and primary to understand. This arrangement of particles in a crystalline solid is in a very orderly fashion। फिग हमारे पास दी गई है, हम देख सकते हैं इसमें क्रिस्टलाइन सॉलिड की पिक्चर्स है। These particles are arranged in a repeating pattern of a three-dimensional network। यानी इसमें इसकी थ्री डिमेंशनल जो होती है स्ट्रक्चर होती है, इसमें पार्टिकल रेगुलरली अरेंज होते हैं और रिपीटिंग अगेन यानी अगेन एंड अगेन होते हैं। दिस नेटवर्क इज नाउन एज क्रिस्टल लैटिस whose smallest unit is a unit cell। If you see the X-ray of a crystal has this distinct arrangement of the unit cell will be clearly visible। यानी अगर हम एक्सरे ये क्रिस्टल में देखें तो हमें इसकी सारी अरेंजमेंट नज़र आ जाएगी। The spaces between the atoms are very less due to high intermolecular forces। इसमें मॉलिक्यूल्स एक दूसरे के एटम्स बहुत ही करीब होते हैं एक दूसरे के ड्यू टू हाई इंटरमोलिकुलर फोर्सेस, अटैच होते हैं बहुत ज़्यादा, which results high melting and boiling points। The intermolecular force is uniform throughout the structure। यानी इसमें इंटरमोलिकुलर फोर्स भी पूरे स्ट्रक्चर में यूनिफॉर्म होती है। Crystals have a long range order, which means the arrangements of atoms is repeated over a great distance। आगे है हमारे पास properties of crystalline solids। These solids have a particular three-dimensional geometrical structure। Number 2, the arrangement of the ions in crystalline solid is of long order। Number 3, strength of all the bond between different ions, molecules and atom is equal। Melting point of crystalline solid is extremely sharp, mainly because the heating breaks up the bond simultaneously। The crystalline solids are anisotropic as the physical properties like thermal conductivity, electrical conductivity, refractive index, and mechanical strength of crystalline solids are directional dependent, i.e. these vary along different directions। These solids are the most stable solids as compared to others। नेक्स्ट है हमारे पास सॉलिड्स क्लासिफिकेशन की सेकंड टाइप amorphous solids। Amorphous solids are rigid structure but they lack a well-defined shape। They do not have a geometric shape, so they are non-crystalline, and they do not have edges like other crystals। This variation in characteristics of solid occurs due to the arrangements of their molecules। Here the particles of matter do not form the three-dimensional lattice structure that we see in solids। Some naturally occurring amorphous solids have impurities that prevent such a structure from forming, so they have a short order arrangements of molecules. The most common examples of an amorphous solid is glass, gels, plastic, various polymers, wax, thin films are also good examples of amorphous solids. हमारे पास है properties of amorphous solids. Number 1, strength of different bonds is different in amorphous solids. Number 2, there is no regularity in the external structure of amorphous solids. Number 3 है amorphous solid don't have sharp melting point. This is due to the variable strength of bonds present between the molecules, ions or atoms. So bonds having low strength on heating break at once, but the strong bond takes some time to break. Amorphous solids are isotropic in nature. Isotropic means that in all the directions their physical properties will remain same. नेक्स्ट है हमारे पास क्रिस्टलोग्राफी. द स्टडी ऑफ द स्ट्रक्चर ऑफ क्रिस्टलाइन सॉलिड इज कॉल्ड क्रिस्टलोग्राफी. आगे है हमारे पास क्रिस्टल स्ट्रक्चर. A crystal structure is because particular arrangement of atoms. A crystal lattice is made of points. A crystal system is set of axes. In other words, the structure is an ordered array of atoms, ions, or molecules. Crystal structure is obtained by attaching atom groups of atoms or molecules. These structures occurs from the intrinsic nature of the constituent particles to produce symmetric pattern. A small group of a repeating pattern of the atomic structure is known as the unit cell of the structure. A unit cell is the building block of the crystal structure and it also explains the entire crystal structure and symmetry with the atomic positions along with its principal axis. The length, edges of principal axis and the angle between the unit cells are called lattice parameter. Next है हमारे पास crystal translation vectors. Imagine the points in space about which atoms in crystal are located. These points are called as lattice points. Thus, an ideal crystal is a body composed of atoms arranged on a lattice defined by three fundamental translation vectors A, B, C, such that the atomic arrangement looks the same in every respect when viewed from any point R as when viewed from the point R prime. Thus, अब हम इनके आगे फिगर्स देख लेते हैं कि हमारे पास क्या दिया गया है. इनकी इक्वेशंस हमारे पास इक्वेशंस है आर प्राइम इज इक्वल टू आर प्लस टी. आर प्राइम हमारे पास आर ये सब हमारे पास वेक्टर फॉर्म में है. आर प्राइम इज इक्वल टू आर प्लस n1 a प्लस n2 b प्लस n3 c, where n1, n2 and n3 are arbitrary integers and t is called a lattice translation operation or crystal translation vector. The crystal translation operation is defined as the displacement of a node necessary to its crystal translation vectors. T हमारे पास है n1a plus n2b plus n3c. In two-dimensional lattice, the vector t connected to any 2 points and given by the following relation. यानी अगर हमारे पास 2-dimensional lattice होगा तो उसमें वेक्टर t 2 पॉइंट्स को कनेक्ट करेगा A एंड B, और अगर हमारे पास 3-dimensional होगा तो 3 पॉइंट्स को कनेक्ट करेगा यानी A, B, C. नेक्स्ट हम अपनी अगली वीडियो में पढ़ेंगे इंशाअल्लाह.